Hi, everybody. Welcome to the last part of our discussion. So, as I've told you, please check the description for the link of our video presentation because this video was divided into four different parts to have you the specific video presentation for each of the concept. And because we are talking on the mall concept, and we are in the last part, which is the sum up or the summary of the four of the three that we have discussed a while ago, which is the the grams to moles, the conversion of atom to moles, the molecular mass and as well as the percentage composition. But for this is just a sum up of the atoms. If we discuss about the moles to atom conversion, this is quite the same, but the difference here is if we are using the atoms to moles conversion, we are pertaining to a single element, but this one we are pertaining to a compound. Okay, so that's the reason why we are going to calculate the grams or to convert from grams to moles and moles to grams. This is a vice versa computation. If the number of moles is given, then we are going to find the number of grams. If the number of grams is given, then we are going to find the number of moles. So in our module, I put there a very clear presentation of the discussion on how to calculate that one. The first one here is you are going to convert from grams to moles. Then, so you are going to find the number of grams or the number of moles in that certain grams. Okay, so we have here the number one question is determine the number of moles of carbon dioxide in 454 grams of carbon dioxide. So I hope that you have watched the video first of the molecular mass on how to find the total molecular mass of a compound, because we will use that in this conversion. Okay, so determine the number of moles of CO2 or the carbon dioxide in 454 grams of carbon dioxide. So first one there is we need to find the total atomic mass or the molecular mass of that compound, which is equal to 44.011, or we have that a while ago in the previous video. Okay, the total atomic mass of carbon is 12.011 and the total mass of oxygen is 16 times 2. That's the reason why you have 32, and the total of them is 44.01. So that will be the total atomic mass. So we will be using this one as our dividend. Okay, this 44.1, this is equal to 1 mole of carbon dioxide. So we are no longer using the Avogadro's number here because this is no longer an individual element. That's the reason why whatever the total molecular mass of a compound, that is equivalent to 1 mole. So I put here thus 1 mole of carbon dioxide weighs 44.01 grams. So that will be the total weight or the total mass of that compound. So this relation provides the conversion factor to go from grams to moles using the factor 1 mole is divided by 44.01. So the number of moles of carbon dioxide here is equals to 454. Where did we get this 454 grams? That is the total grams of the carbon dioxide. So 454 grams times 1 mole over 44.01. So where did we get this one? That is the total atomic mass of the compound carbon dioxide, and we get the number 10.03 moles. Okay, just you can also do that in shortcut, which is you can do that in shortcut, which is 454 dayon divided by, where's my divided by here, divided by 44.01, okay, equals, so the answer now is 10.31, or if we will write the digit after the decimal point, that will be 10.36 grams. Okay, 10, because we will be looking for moles. That's the reason why our answer is there will be 10.3 moles here the answer, or 3.36 moles of carbon dioxide in 454 grams of carbon dioxide. So just simple as that. Okay, simple as that. If you are going to find the moles, then just use divide. Okay, so the number of moles is equals to the grams divided by the total atomic mass of an element. Okay, let's proceed to the second conversion, which is moles to grams, because the first one is grams to moles. For the moles to grams, number 2 here, find the number of grams. Okay, sorry, I was not able to show you my, okay, here, tara. So as I've told you, this is about 10.36 moles of carbon dioxide. There are 10.36. Where did you get this one? So just divide the number of grams of that compound divided by the total atomic mass, okay, to find the number of moles. For number 2 here, the second one is a conversion of moles to grams. So find the number of grams in 0.700 moles of hydrogen peroxide, or H202. So that means there are 2 hydrogen and 2 oxygen in that certain compound. So what we're going to do here is grams of the sample equals molar mass times the moles. So if in the first one, if the grams to moles, we use the division, okay, the division. In this one, in the moles to grams, we will be using multiplication. Okay, so let's try. Still the same, using the molecular mass. Find the molecular mass for the hydrogen. There are 2 hydrogen in that certain in that compound. So the hydrogen is 1.08. I'm not sure if this is correct, so we will see our periodic table. So this is the hydrogen here. So okay, the atomic one amo to ilaha kay 1.008. So the atomic weight for hydrogen is 1.00794 times 2, because there are 2 hydrogen in that okay. So let's proceed to the oxygen. So how much is oxygen? We already know that oxygen is 16, or 15.9994. Okay, so the oxygen is 16. You can use also 15.994. You can use this one, or you can use 16. Okay, but either of the two. Okay, now let's proceed to our discussion. Okay, so here multiplied by 2, then add the 2 in order to get the total atomic mass. So our total atomic mass for the hydrogen peroxide is 34.016 grams. Okay, grams, that is grams per moles. So let's proceed. Grams, to find the grams of hydrogen, we are using multiplication. So use this formula. The grams of sample equals to molar mass, which is 34.0116. This is the molar mass of the 2. And then multiply the moles. Okay, multiply the number of moles here. Then you have now the 23.811 grams of hydrogen peroxide. Okay, so you have now your answer. So in your answer, there are 23.811 grams of hydrogen peroxide in 0.700 moles of hydrogen peroxide. So I hope now that you can get. So just go back to your module if you have your mga kalibug-libugan. So let's see your activity. So this is your activity 5. The number 1 here is determine the number of moles of CCl, or the carbon this is carbon, and this is the carbon chloride. Okay, in 64 grams of CCl4. Okay, so we don't have the chlorine here. So let's proceed to our pilaman at periodic table. Pilaman atong chlorine. So number 17. So the element chlorine is 35. Okay, this is the atomic weight. So copy in your module para nga naamoy kuan. That is Cl, the Cl is equals to 35.4527. Okay? 4527, that is the atomic weight for chlorine. And for the number 2 is, because carbon dioxide, we already know the carbon dioxide is equals to 12.011. For the number 2 is the nitrogen and hydrogen. So we know that hydrogen is equals to 1.008. And for the nitrogen, number 7. So nitrogen, this is the atomic weight for the element hydrogen, which is in hydrogen. Nitrogen is equals to 14. This is for number 2, 14.0067. Okay? So you have now, I'm sure that you can answer that already, even if you don't have your periodic table of element, because I already put that one in our video. So I will also put that one in the description of this video. Now, let's proceed to the calculation to determine the number of moles in the 64 grams of CCl4. Okay? So first one is we are going to find napalo na akong cellphone. You are going to find for a while. Let's proceed. Wala na ha. Okay. Now, let's proceed. To. This is Cl. Okay, this is Cl. The carbon is equals to 12.011. Okay, if I'm not mistaken. So that will be the atomic mass for the carbon. So let me check here if I have the carbon. The carbon here is 12.01. Okay, I got it right. So let's proceed to our... Okay, let's proceed. Using the formula, because we are going to look for the number of moles of Cl. Okay, determine the number of moles. So to determine the number of moles, this is here. This is the same in the example number 1. So you are going to look for how many how many chlorine is there. There are 4. So multiplied by 4. Let's try. So how many? Pila naman ang ato ang kuan ron is for a while. Let's use our calculator. So that will be 35.4527 dayon times 4 is equals to 100. Our total chlorine is equals to, di na mo agi akong kuan, equals to 141.8108 dayon. So our total molecular mass of of CCl4 is equals to pila naman 4. Nagkuan ba diri? Ay, wala man day. I'm sure I was thinking it works dinhi. Okay, so plus pila 12.011 equals, so we have now our total mass of the CCl4 is 100. Di naman mo agi ako ang kuan. Is 100. Kung kinsay ganahan mo donate og whiteboard marker. Di na mo agi. 153.8218. Okay? So check this in your calculator if we have the same answer. Okay, 153.8218. So that will be our molecular mass of CCl4. Now, what should we do next is you are going to, that means it is, or this is grams per mole. Okay, equivalent to grams per mole. So what we will do next using the formula here is the moles of carbon moles of CCl, okay, moles of CCl4 is equals to how much is the grams there? Is equals to 64 grams times 1 mole. Nagtakilid kamo na i-adjust 1 mole because the total grams here is mapalong siya kuan equals 153.82 di na kay mo agi grams. Okay, so equals pila na? So my canceled out the grams, so the remaining is moles. So let's try to see if we are in the right track. So let's try to calculate. Okay, so 64 grams divided by 153.81 8218 is equals to 0. That means 0 na di na mo agi kinsay ganahan mag-donate og kanini ang whiteboard marker 0. Haraman to akong 0.416 moles of 16 moles. So that means our answer now is there are 0.416 416 moles of CCl4 in 16 grams of CCl4. Okay, so you can do now the second part, which is a reverse conversion from grams to moles. So we are now done calculating. So I put there solution is a must. So probably you can put the answer there directly, but I will not consider that because I need the solution on how you arrive in that answer. So this is how you are going. This is the answer now. Okay, ipalayan akong camera. So there are 0.416 moles of CCl4 in 16 grams of CCl4. Now the second one, in the number 2, you are going to find the number of grams in 6.8 moles of nitrite. Okay, nitrogen, and this is there are 3 hydrogen here. Okay, so I already given you the atomic mass of nitrogen, and the hydrogen is very common. Okay, so I hope that you understand our discussion for this tutorial. So you can go back to your modules and answer that. Okay, narasya dire. Okay, so kung malibog mo, just click the link on our in the description below, or you can also comment or unsay pa inyong malibugan so that I can give you the clear discussion na pod aning atong subject. Okay, God bless everybody. Keep safe and bye-bye.